Alright, complex numbers is a very difficult topic. So today we're just going to review all the things that we talked about in the last video for complex numbers. Alright, so we have the square root of a negative 18. Remember that negative on the inside is the imaginary unit, and I is the same thing as the negative 1 square root. So if I wanted to, you don't have to do this, I could rewrite this as a negative 1 times 18 and break that into two pieces. The square root of negative 1 times the square root of 18. Well, this negative 1 is going to be replaced by the I component because I is a negative root of 1. So we break down the 18, 9 and 2, 3 and 3. That means the 3 goes to the outside and the 2 is stuck over on the inside. So when we put the fact that I have got an I from the negative times the 3 root 2, this becomes 3I root 2. Notice that there's no plus or minus. Until now, we move the 8 over. We've got x squared is equal to a negative 6. Here we were just evaluating. Here I'm solving for some unknown value. When I'm solving for a variable that's being squared, I add the plus or minus. The negative on the inside creates an I component on the outside to take care of that negative because there can never be a negative left over on the inside. When I try to break down 6, there's no matches, so that's x is equal to plus or minus I root 6. Next one, we still want to solve for an x squared, but we have x caught inside of this squared quantity, which is a little bit different than just an x squared. First, we want to isolate these parentheses. We've got to get them by itself. So I move the 2 over, and we've got 2 times the quantity x plus 3 squared is equal to a negative 40. Now I still don't have the grouping by itself, so the next thing I have to do is divide by 2. And we've got x plus 3 quantity squared is equal to a negative 20. Now that I have finally isolated the quantity that's being squared, I can undo the square symbol. The opposite of squaring something is taking the square root. The square root and the square cancel each other out, leaving us with an x plus 3 is equal to, we've got to add that plus or minus in there. The fact that I have the negative means that there's going to be an I on the outside. We break down 20, 4 and 5, 2 and 2. So we've got a pair of 2, so the 2 gets to go on the outside, and the 5 is stuck over on the inside. Now x is still not by itself, so the last step is moving the 3 over. We've got x is equal to a negative 3 plus or minus 2I root 5. We cannot combine those two pieces together because one has an imaginary unit and it has a radical, and this is just a number. So only combine things together that are like terms. Just don't forget that you have two solutions here. That is a negative 3 plus 2I root 5 and a negative 3 minus 2I root 5. So you have two separate answers here. One when you're adding, one when you're subtracting. So don't forget that that is representing two different pieces. Now let's review our operations with these imaginary numbers. If I am multiplying, we have to FOIL binomials. So 4 times 3 is 12. 4 times a negative 2i is a negative 8i plus 3i minus 2i squared, which brings us to another new thing that we learned. I squared is equal to a negative 1. So when I see that I squared there, I'm going to take it out and I'm going to plug in a negative 1. So this is really 12 minus 5i minus 2 times a negative 1. And 2 times a negative 2 times negative 1 is a positive 2. So we've got 14 minus 5i. And don't forget that your equation or your expression here needs to be in standard form. That's your number plus your imaginary component. And obviously this is adding a negative 5, so it doesn't matter if that's a plus or minus. In the next piece, you want to make sure that you're paying very close attention to what operation you're performing. And the last one, there was no symbol between the parentheses, so I was multiplying. Here, I'm not multiplying, I am subtracting. So I've got to distribute that negative. So 5 plus 2i, nothing's changing there, minus a negative 3 is a positive 3 minus 6i. And then it's simply combining like terms. So 5 plus 3 gives us 8. 2i minus 6i is a negative 4i. And our next one, we've got 8i times this quantity. There's no symbol separating the term and the parenthesis, which means it's multiplication. 8i times 3 is 24i. 8i times 2i is 16i squared. Don't forget about the I squared. That I squared really is a negative 1. So that's 24i minus 16. The 16 needs to come first. So I've got negative 16 plus 24i. And this is our last problem. Alright, in our last problem we are dividing imaginary components. Remember, I is equal to the square root of a negative 1. I can't have square roots on the bottom of my fraction, so I've got to get rid of it. To get rid of it, we multiply by 3 plus 2i. And we're going to multiply that on the top and bottom. When we multiply by that 3 plus 2i, that is something called the conjugate. We didn't talk about the vocab yesterday. There was a lot thrown at you in the 5-4 video. So just know, anytime I'm referring to the conjugate, that's what I'm talking about. It's the same, one's a plus, one's a minus. Alright, so now we need to FOIL. So 4 times 3 gives us 12. 4 times 2i is 8i, plus 3i, plus 2i squared. Then we FOIL out the bottom. 3 times 3 gives us 9, plus 6i, minus 6i, minus 4i squared. Go ahead and combine like terms on top. 8i and 3i gives us 11i. That's really a negative 1, so it's 2 times negative 1. On the bottom, 6i minus 6i. The whole purpose of multiplying by the conjugate is to get rid of those middle terms. That way I no longer have a square root on the bottom. So I've got 9 minus 4, and again, I squared is a negative 1. So on top now, we've got 2 times negative 1, that's a negative 2. So 12 minus 2 gives us 10, plus 11i on top. Negative 4 times negative 1 is a positive 4. 9 plus 4 is 13 on the bottom. 10, 11, 13. All three numbers don't share any factors, so there's nothing that can be reduced there. Alright, that's all for your review day on complex numbers.